Welcome back, mathematicians. In this video, we are going to learn about functions. Let's start with the definition of a relation. A relation is the correspondence between two sets. Now, these can be two sets, any two sets. It can be a set of values. It can be a set of descriptions like maybe pets and their owners. It really is open-ended for a reason. Now, let's define a function. A function is a relation. So we're taking a relation and we're narrowing down the definition to be a little bit more specific for it to be considered a function. So it's a relation where each element of the input corresponds with exactly one element of the output. And what I've included here are three mapping diagrams where the first column represents values for my x variable, which is my input or independent variable, and values of my y variable, which is my output or dependent variable. And what you see is the correspondence from x to y using arrows. And so we see that 1 is corresponding with 3, 3 with 5, 6 with 8, and 10 with 12, meaning that each element of my independent variable is corresponding with one element of my dependent variable, meaning that this relation represents a function. My second mapping diagram, I have 2 corresponding with 6, 7 corresponding with 4. So far, so good. That means that it is a function at this point. I have 9 corresponding with 6. And so some people interpret that to be not a function because both 2 and 9 are corresponding with 6. But again, let's go back to our definition, a relation where each element of the input corresponds with exactly one element of the output. It doesn't mention here that they can't share that same output. So in this case, because 2 and 6 both have one element in the output, both namely 6, it is still considered a function at this point. And so 13 is paired with 10, so yes, this is in fact a function. So the first two relations are considered functions. Now let's look at our third example, where we have 6 corresponding with 5. We have 3 corresponding with 15. So far, so good. They're both corresponding to one value. And so now we have 0 corresponding to not just 6, but also 10. And so because 0 is corresponding with 6 and also 10, this actually goes against the definition of a function, meaning that this mapping diagram, it does represent a relation, but it's not a function. So just again to be clear, the second mapping diagram was a function, even though we have both 2 and 9 corresponding to 6, but the third mapping diagram is not a function because you have 0 pairing or corresponding with 6 and 10. So anytime a value in your input or your independent variable is corresponding to more than one values in your output or your dependent variable, it means that it is not a function. Let's look at two more examples where we are given a relation. In this case, we're given a series of ordered pairs, and we're asked to determine if these relations represent a function. So some of you might be able to just look at the ordered pairs and see the correspondence of yes, this represents a function, or no, it is a relation, but not a function. However, we can go ahead and make a mapping diagram to maybe present a visual that will allow us to verify if the relation is a function or not. So I'm going to make a list of my x values, and I'm going to make a list of my y values. I like to do this from least to greatest with my values. So I have the least greatest is -1 for my x variable. Then I have 2, 4, and 5. Then I have for my y values a value of 2, 3, and 6. Now the correspondence is represented in the order pair, so 2 is paired with 6, so therefore I'm going to make an arrow from 2 for my x variable to 6 with my y variable. I have 1, -1 corresponding with 3, so -1 to 3. I have 4 to 3, And then finally, I have 5 corresponding to 2. Now, because every element of my input is corresponding to one element in my output, I know that this is a function. Let's go to the second example, where again I will make a mapping diagram. So I have values for my x variable of -1, 0, and 3. Now you'll notice that 0 is represented twice, but we only put it once in the first column. I then have y values of 1, 2, 4, and 5. And now I'm going to draw my arrows to represent the correspondence. So I've got 0 corresponding to 1. I've got -1 corresponding to 2. I have 3 corresponding to 5. And then 0 corresponding to 4. And as we can see, we have 0 as my input corresponding to 1 and also 4, which means this is not a function. So again, it is a relation, but that relation does not represent a function. All right, guys, good luck.